Hello everyone, welcome back to Chemistry 24/7 series. In this series, we have been exploring the solution for previous year competitive exam papers. If you are new here, don't forget to subscribe and hit the bell icon for notification. So let's see what's today's problem. So this is the problem from the continuation of our LDA series. So as per this question, the intermediate A and the major product B in the following reaction are, so this question from CSR 2017. So here you see do-bromo anisole react with LDA and followed by anion of dimethyl malonate which produce intermediate A. This intermediate A further converted into product B. So here there are four options are given. Let's solve together which one is the correct option for this question. The first step of the reaction is 2-bromoanisole react with LDA. So LDA we have already discussed a lot in our channel and their preparation, properties and application. If anyone missed that video, you can find the link in the description box below. So LDA is one of the non-nucleophilic sterically hindered strong base which readily abstract the proton from more acidic position. So when you come to our substrate to bromoanisole, particularly this CH position is more acidic. Since so here you see this position has bromo atom and this position has methoxy group. So both group withdraw the electron by inductively, which makes that this position is more reactive. So therefore LDA readily abstract the proton from this side which produce this corresponding species. Now this negative charge moves here, so resulting that kick off Br minus which produce benzyne intermediate. So benzyne intermediate is one of the more reactive intermediate. So this intermediate going to react with this anion of dimethyl malonate. So before that here we should note that regioselectivity. How this anion of dimethyl malonate going to react with this benzyne intermediate. So for this, we should know the electronic nature of benzyne intermediate. I hope that most of them aware about the benzyne regioselectivity issues. So if you go through your textbooks, so you can find the solution based on the substituent present in this particular position. We could easily predict the regioselective nature of the reaction. For example, in this particular intermediate has methoxy group as a substituent. So we know that methoxy group could release the electron by mesomerically. So apart from that, methoxy group can withdraw the electron by inductively also. So however, whenever you deal the benzyne chemistry, you just forget about the mesomeric effect. Since let's think about how this triple bond is formed. So here you see this triple bond contains one sigma bond and two pi bonds. So one of the pi bond present inside of the ring and another pi bond present in the outside of the ring. So the sigma bond is formed in between two sp2 hybrid orbitals. In case of this pi bond present inside of the ring is formed in between the overlap of p orbitals contribute the conjugation. So when you come to this pi bond, so which one is present outside of the ring system, so this pi bond formed in between two sp2 hybrid orbital. So which means that this pi bond doesn't contribute the conjugation. So therefore here inductive effect only the major contributing factor for the electronics of benzyne ring system. So here this methoxy group act as a electron withdrawing group by inductively, which means that minus I effect. So based on that, so here you see this methoxy oxygen now pulls the electron from this center, which makes that this center is slightly electron deficient. In case of this position is like slightly electron rich character. So now anion of dimethyl malonate react with benzyne, particularly this position. Now this negative charge attack this position, so resulting that these pi electrons move towards this carbon atom which produce this corresponding intermediate. So this is our intermediate A. So this intermediate A in next step going to convert into the product B. So let's see how this happens. So for our convenience, you just redraw the structure like this. Now this negative charge attack the carbonyl carbon of this ester group. So now these pi electrons move towards the oxygen atom which produce this corresponding fused four-member ring system containing intermediate. Now this O negative charge moves here, so resulting that cleavage of this carbon-carbon bond. So these electrons move towards this carbon atom. Now these pi electrons move towards the oxygen atom, which produce this corresponding intermediate. When we do the workup, so which readily abstract the proton from solvent, which produce this corresponding product. So let's moving to the our question. So as per our discussion, among the four answers, the correct option for this question is option 1. That's it for today's problem. I hope this explanation has helped you to understand this question. If you enjoyed this session, just give it a thumbs up and share it with your friends, and don't forget to subscribe ChemOrgChem for much more content like this. And finally, thanks for watching. Bye bye.